So if you found the story confusing, I will, which I know some people do find it more confusing than just it being explained to them, I will go through it without the story attached and just go through the different parts and the color-coded parts that are labeled. So first things first, I just want to mention the order of muscle configuration from largest to smallest. You start with the muscle belly, then the muscle fascicle, a myofiber, a myofibril, and a myofilament. Actin and myosin are considered myofilaments. Alright, so in this first image we have a sarcomere, which is one single contractile unit of a muscle. So many of these make up a large muscle, but of course you probably know that. Here we have the Z line, which is where actin is attached to, and we have the midline, which is directly in the middle. M equals middle. That's how you remember, midline. Z is at the end of the alphabet, so you can think Z is at each end of the sarcomere. So right now we have actin, which is in the pink, and it is surrounded by the green filament, which is tropomyosin. But tropomyosin is also attached to these orange dots, which is troponin. Troponin really likes calcium. So when we introduce calcium, troponin gets distracted and wants to interact with calcium. Once troponin is starting to interact with calcium, it drags tropomyosin, the green, out of the way from actin. Now that tropomyosin is out of the way from actin, its actin binding sites are now available. At this point, myosin, which is in a cocked position, and what they mean by in a cocked position basically just means it had run into an ATP, and that ATP hydrolyzed, and now he has an inorganic phosphate and an ADP attached to him. But now that myosin and actin bind, myosin lets go of the inorganic phosphate and has a very strong grip with actin. Now, once myosin is attached to actin, he pulls the actin filament in towards the midline, and this is what causes a contraction, and multiples of this single contraction across an entire muscle is what allows a muscle to contract. Now, this process can continue to happen over and over again so long as myosin gets ATP or energy, because then once myosin gets ATP, we just restart from this position here where it's cocked and the actin binding sites are available to be binded with. If myosin no longer gets ATP, he cannot function and do the grip. And another thing that prevents this from continuing to happen is if calcium leaves the equation. If calcium is no longer present, then we return to this original position where troponin is no longer interacting with calcium and tropomyosin is inhibiting actin binding sites, so myosin and actin can no longer interact.